I wanted to go into just a little bit more detail about how we chose our quadratic coefficient when we were finding the best quadratic to approximate that square root function in class today. So here's the function that we were working with. It was f of x equals square root of x plus 1, and we were trying to find approximations for this near x equals 0. And our quadratic approximation, we decided that it was going to be some number, which I'm calling a here, times x squared plus 1/2 x plus 1. And the criteria that we came up with for choosing our approximating polynomials is that derivatives of the polynomial should match derivatives of the function at the base point. So let's make a little table of the derivatives. So let's have a column for the order of the derivative. Let's have a column for the derivative of the polynomial, the derivative of the polynomial when we evaluate it. We'll have a column for the derivative of the function, and we'll have a column for the derivative of the function when we evaluate it at the base point. Okay, so like this. And so for order 0, remember the order 0 derivative, that's no derivatives at all. So the 0th derivative of our polynomial is ax squared plus 1/2 x plus 1. And when we evaluate that at 0, we get 1. Our original function with no derivatives is the square root of x plus 1. And when we evaluate that at the base point 0, we get just 1. And as we wanted, the polynomial, or the 0th derivative of the polynomial at the base point, is the same as the 0th derivative of the function at the base point. Okay, so now let's do order 1. So now we're looking at first derivatives. So the first derivative of the polynomial is 2a times x plus 1/2. And when you evaluate that at x equals 0, you get 1/2. Now the first derivative of the function is 1/2 times x plus 1 to the minus 1/2. And when we evaluate the first derivative of f at 0, we get 1/2. And as we wanted, the first derivative of the polynomial at the base point is equal to the first derivative of the function at the base point. All right. So now let's look at the second order derivative. So when we take one more derivative for the polynomial q, we get 2a for its second derivative. And when we evaluate that at x equals 0, we get 2a. For the function f, when we take its second derivative, we get minus 1/4 times x plus 1 to the minus 1/2. And when we evaluate this at 0, we get minus 1/4. And now remember, here's the key point. The second derivative of the quadratic polynomial, which is 2a, is supposed to match the second derivative of the function at the base point. So that means 2a is supposed to be equal to minus 1/4. And that tells us that the coefficient on our quadratic term, a, should be minus 1/8. So if you want to find higher degree polynomials to approximate this function, you can use the same trick. Use the derivatives at the base point, set them equal, and you get an equation that you can solve for that unknown coefficient.